And welcome back to Concepts in Arithmetic. We are continuing our work with fractions. And remember, when we introduce fractions, the framework that we're using is partitioning an object into a certain number of parts and then taking a designated number of those parts. Right? For example, 3/4 of something. We cut our pie or cake or whatever into 4 pieces, and then we take 3 of them. Okay, so when we introduce fractions, we're conceptualizing them in that way. But as students progress through the primary school curriculum, they need to transition from thinking of fractions as part versus whole to thinking of fractions as numbers. So we need to be able to do all the arithmetic operations with fractions: addition, subtraction, multiplication, and of course division. So the goal of this video is to make sense of the invert and multiply rule for dividing fractions. So as teachers, we need to be able to explain what division involving fractions means and why it works the way that it does. Okay, to simply say you divide fractions by inverting and multiplying, that's not an explanation. That's just insisting that the process is done that way. And the way we can get students to understand this is to make heavy use of models and word problems. So let's start with a review here. So case 1 is going to be a review of division of whole numbers. Okay, so in this example, let's say 2 girls share 5 cookies equally. How much should each get? Now, for each of these scenarios, I will be indicating whether we're thinking about this in terms of measurement division or partitive division. And in this example, I've already circled partitive, right? We're taking the 5 cookies, we're dividing them into 2 parts, and we want to know how big those parts are. So partitive division. Okay, so we have 2 ways to think about this. Either way, we're going to get the same answer, so that's good. Okay, so we have, and our thinking is this right here. 5 is 2 groups of what? Okay, so that's how we're interpreting this division. We have the 5 cookies, that's 2 groups of what? What's the size of that group? Well, we got these 5 circles representing the 5 cookies. I just sliced them right down the middle right there. So half of the group is on this side, half of the group is on this side. And we can see from the picture that's 2 1/2 cookies. So each girl gets 2 1/2 cookies. You could have sliced it into 2 groups the other way, right? You have your 5 cookies, slice it this way. Okay? So half a cookie, 1 cookie, 1 1/2 cookies, 2 cookies, 2 1/2 cookies. It's still 2 1/2 cookies, or you could visualize that as 5 half cookies. Okay, 5 halves of a cookie, the improper fraction related to this mixed number. Okay, so let's go and check out case 2 here. Taking a fraction divided by a whole number. All right, let me grab a different color to do some of these problems here. Add a little more interesting stuff to the mix. Okay, so we have 4 boys sharing 2/3 of a quart of juice equally. How much do they get? Okay, so here's where our thinking is. 2/3 is 4 groups of what? Okay, so 2/3 is 4 groups of what? So we know how many groups we have, so we are working with the partitive division model. We have 4 groups, we need to know how big they are. So let me start by illustrating 2/3. with a little bar diagram. Okay, I don't need that there. Okay, so 2/3, got my bar diagram. I carved it into 3 pieces and I'm picking 2 of them. Okay, so that's our old interpretation of fractions. All right, now I'm taking this 2/3 and I want to divide it into 4 pieces. Okay, now lucky for us, the 2/3 is naturally already divided into 2 pieces. So what I can do is I'll just take each of those and cut them in half. Okay, so the question is, what is this? Well, if I look at the size of my pieces here, I can see that ends up being, actually let me do this in stages here. Okay, that'd be 1/3, and if I did half of that, that'd be 1/6. Okay, so two-thirds divided by 4, that is equal to 1/4 of 2/3. If you look back to our notes on multiplying fractions, one of the key interpretations was this of interpretation, okay? So I took my 2/3, divided it into 4 pieces. So I'm looking at one of those 4 pieces, 1/4 of the 2/3. Okay, and we know that interpretation. That's 1/4 times 2/3. Or if you want to use the commutative property, that's 2/3 times 1/4. And you get 1/6 from doing that. Okay, so, oops, I'm in the way, but that's okay. Scooch up a little bit. Okay, so 2/3 divided by 4 is equivalent to taking 2/3 times 1/4. Okay, so we're moving toward that invert and multiply idea. Okay, here's another example. It's not a word problem. I want to illustrate this division using an area model. Okay, so 6/7 divided by 3. So I want a picture that represents 6/7. All right, so what I'll do is 1, 2, 3, 4, 5, 6, 7. Okay, so here's a picture representing 6/7. I took a rectangle, I sliced it into 7 equal pieces, I'm shading 6 of them. Okay, so if we're talking about dividing this by 3, what we want to do is we want to break it into 3 equal pieces. Okay, so we can do that this way. I'll take this whole rectangle and I'll go the other way and I'll break it into 3 pieces that way. Okay, now let me think about what I got here. It looks like I got 21 pieces, okay? Now, if I'm breaking this up into 3, here's what I'd be doing. I'd be taking that, okay? That's one of the groups, okay? So if I take, let's say I'm talking about whole numbers, right? If I take 12 divided by 3, I take 12, I break it up into 3 equal pieces. Each of the groups would have 4 items in it, right? So I took my 6/7, I broke it into 3 equal pieces. So here's my result from the division there. Okay. So there's 21 total pieces. Okay, so 6/7 divided by 3. That's 1/3 of 6/7. Whoops, gosh, I'm always in the way. Get out of the way. Okay. That's 1/3 times 6/7, or if you like, 6/7 times 1/3. Now you can see where that 21 is coming into play that we were talking about just a second ago. Right? We got 21 total pieces when we break that up. We're taking 6 of them. Now, of course, this fraction can be simplified here. Both of these have a factor of 3, so that's 1/7. Okay. Let's go on to case 3 here. Taking a whole number, dividing it by a fraction. Okay, so Jill bought 5 oranges. She cut them into halves. How many pieces? And let's say, how many pieces did she get? Okay. So, when we are thinking about this problem, we're thinking about it like this. 5 is how many groups of 1/2. Okay, that's our thinking. And when we write out this question, we can tell what kind of division interpretation we're doing. Okay, so 1/2 is kind of like our ruler, and we're going to measure off 1/2 until we get to 5. Okay, so it's not too hard to come up with a very nice interpretation. Oh, I'm even using an orange pen, so that's fun. 1, 2, 3, 4, 5 oranges. We're cutting them in half. 1, 3, 4, 5. Okay. So, when we see that here, we can clearly see we have 10 halves. Okay, so in other words, 5 divided by 1/2, well, each of the single units in the original scheme is going to get broken up into 2 things. Okay, so this is equal to 5 times 2, giving us 10 half oranges. Okay, so the idea is that dividing by 1/2 is equivalent to multiplying by 2. Okay, dividing by 1/2 is equivalent to multiplying by 2. Let's look at another example here. We're talking about a whole number divided by a fraction. Okay. So here's our scenario here. Jim is walking to Kim's house. After 6 blocks, he is 3/4 of the way there. How far apart are the houses? Okay, so let's think about an interpretation. So what we're thinking here is 6 is 3/4 of what? Okay, so 6 is 3/4 of what? This is actually partitive division. We need to know how big the pieces are. All right. So we can actually do this very nicely with a little bar diagram. Okay, so 1. So I take my bar diagram, I break it up into 4 pieces. I'm going to look at 3 of those pieces. This corresponds to the 6 blocks that he has already traveled. So the entire bar represents the distance from Jim's house to Kim's house. we know that 6 blocks corresponds to 3/4 of that entire distance. Okay, so we can interpret that by doing this, right? 3 units equals 6 blocks. Therefore, 1 unit equals 2 blocks. So the entire distance, which is represented by all 4 units, equals 8 blocks. Okay? So if I'm taking 6 divided by 3/4, let's look at what we did here. We took the 6 and we divided by 3. Oink. Okay? So right, that's how we got this. So we took the 6, we divided by 3, then we multiplied by 4. Okay? So this is 6 divided by 3 times 4. Okay, now we know that fractions and division are equivalent, right? 6 divided by 3, that's the same as that fraction. And that's the same as this. 6 times 4 divided by 3. Okay, you can switch those operations, still get the same answer. Okay, so dividing by 3/4 is equivalent to multiplying by 4 and dividing by 3. Okay, so once again, getting even closer to that invert and multiply rule through these examples. Okay, so as you're introducing this to your students in the primary curriculum, you're working on getting this started with models and examples. But of course, we do want to eventually go to just the abstract case where the students are working with numbers. Okay, so let's try this. Let's illustrate 6/7 divided by 2/7 using measurement division. So the interpretation when we're dealing with measurement division is something like this. 6/7 is how many 2/7? Okay, so let's illustrate this with a bar diagram. 1, 2, 3, 4, 5, 6, and 7. So I'm taking my bar diagram, I divide it into 7 pieces. I'm talking about 6/7 and 2/7. Okay, so that's 6/7 right there. The shaded squares represent 6/7 of the total diagram. Now 2/7, well, that's right there. So you can see I have 1, 2, 3 groups. Okay, so 6/7, if I take that and I'm breaking it up into groups of 2/7, I know I'm supposed to get 3. Okay, well, let's look at what happens here. If I take 6/7 times 7/2, right, the 7s would cancel here. Okay, dividing by 7 and then multiplying by 7, those operations would just undo each other. I get 6 divided by 2, which gives me my 3. Okay, so another illustration of that invert and multiply principle. Okay, so we can actually see the answer from the diagram. We can see the answer is going to be 3. And we can confirm that the invert and multiply principle gives us that answer.